All right, so if you can open up to the rationals part of your packet, we're going to continue on from where your ed puzzle left off last night. All right, so last night you guys watched an ed puzzle that went over, I'm going to actually skip past these ones, numbers 1 and 2 from this first page here. So what we're going to do is we're going to take a look at number 3. So let me just move this up, make this a little bigger. Okay, so what I'd like you to do is I'd like you to look back at your work from numbers 1 and 2 and see what we did, right? What do you do when they want you to determine what makes the fraction undefined? And try out number 3 on your own, okay? You can hit pause and try it out, and then when you're done, hit play and see how you did. Now, if you recall, a fraction is undefined, right, when the denominator equals 0. So if we want to figure out what makes this fraction undefined, what we're going to do is we're going to just ignore this numerator, okay? That doesn't matter. We're going to take the denominator and set it equal to 0. So that's what I did right here. I took the denominator and set it equal to 0. All right, and then all you have to do is solve. Now, you could solve this. I mean, you can use the quadratic formula if you want, right? This is a quadratic, but this one right here, this is a pretty straightforward factoring example, so I'm just going to do it through factoring. So since we have a 1 in front of our first term, I'm going to set up 2 sets of parentheses. And I'm going to put x in the first spot in each of those parentheses because x times x gives us x squared. And I don't want to forget my equals 0, right? You have to keep it an equation the entire way through. And then we just have to come up with 2 numbers that add to positive 2 and multiply to negative 8. So that would be positive 4 and negative 2. And then we're just going to make a t-chart and solve. So on the left side of the t-chart, we get x equals negative 4. And on the right side, we get x equals positive 2. Okay, so it looks like that matches up with choice 1. All right, so let's flip to the next page. All right, so this page talks about simplifying fractions. Now, on last night's video, right, you guys went over number 4 and number 6 on the Ed Puzzle video. So what I'm going to do is I'm going to just focus in on number 5. Okay, so just like we did on the previous page, I'd like you to take a look at what we did on number 4 and 6 and see if you can apply it on your own to number 5. Okay, so you can pause the video, try it out, and then when you're done, hit play to check your work. Okay, so in simplifying a fraction, we know the first thing we want to do is we want to factor the numerator and factor the denominator. Now, when I look here, when I look at this numerator, 6 minus x, I mean, there's nothing that can be factored, so I'm just going to take the 6 minus x and just bring it right over. Okay, now when I look at this denominator, this can be factored. And I'm going to do this off to the side just so I don't make like a whole big mess within my fraction here. All right, so let's see. We have 4x squared minus 144. Okay, so our first step in factoring is, can I take out a greatest common factor? Now, some of you may have looked at this and said, oh, look, this is a difference of perfect squares. And you might have jumped right into factoring dots, but don't forget about that first step, right? If you can factor out a greatest common factor, which in this case would be 4, you want to do so. All right, so when I pull out the 4, I'm left with x squared and then minus, right? I took the 4 out, so I bring down the x squared. And 144 divided by 4 is 36. Okay, now if we look in our parentheses, we can see, look, this is a difference of perfect squares, so we can factor further. So I'm going to take the 4 and bring it down, and we know with dots, right, difference of 2 squares, we open up 2 sets of parentheses, we put the square root of the first term in the first spot in each parenthesis, we make 1 addition and 1 subtraction, and then we put the square root of the second term in the second spot in each parenthesis. All right, now, I mean, nothing here can be factored further, so what we're going to do is we're going to take this and move it up to the denominator of our fraction. So we have 4 times x plus 6 times x minus 6. Okay, so step 1 is done. We factored everything that we could factor. So now from this point, we want to cancel anything that can cancel. So, I mean, in order to cancel, right, usually you want to look for the same exact thing somewhere on the top as we have on the bottom. Now, we don't have the same exact thing, but if you recall from last night's video, right, the Ed Puzzle video, if you have a binomial that says the same thing but in the opposite order, right, this says 6 minus x, and this says x minus 6, you're allowed to cross them off. But remember, if you cross them off, you have to put a -1 somewhere to compensate. Okay, I'm going to put it right up on the top. And really the reason we're doing this is because if you look in the numerator, right, we have a +6 and a -x, whereas on the bottom we have a -6 and a +x. So since they have the opposite signs, you know, really it's just like pulling a -1 out of one of them to make them the same. Okay, now, I mean, on the top, since all we're left with is -1, there's nothing that we can cancel in our numerator with our denominator, so I'm just going to take this and just bring it right over. So we're left with -1 over 4 times x plus 6. All right, and that's it. I mean, if you want, another answer that would be acceptable would be if you want to distribute this 4 into the parentheses, so that in our denominator we have 4x plus, and then 4 times 6 is 24. You can have that. And then also, if you want, like this negative sign can go anywhere. A lot of times, like in a multiple choice, you'll see it in front of the fraction. So if I want to take this negative and pull it up front, I can. And then I'm just left with 1 on top. Okay, so this is another acceptable answer. All right, if you can turn to the next page. The examples on this page, I mean, they're a little harder. But I still would like you to try them on your own, right? And then, you know, hit play and see how you did. All right, so number 7, we're going to start this off, right? Same way we did number 5. If you want to simplify the fraction, right, they're asking us to write it in simplest form, you want to factor the numerator and factor the denominator. So I'm just going to put my little fraction bar right here. Okay, so the numerator, right, this right here is a difference of 2 squares, okay? So if this is a difference of 2 squares, we set up 2 sets of parentheses, and we put the square root of the first term in the first spot in each parenthesis. So the square root of c squared is c. We make 1 addition, 1 subtraction, and then we put the square root of the second term in the second spot in each parenthesis. Okay, so the square root of d squared is d. All right, now, in order to factor the next term, the denominator, I mean, you can do it a couple different ways. To me, I just look at this. See, we see a d squared. Same thing as 1d squared, right? So if we have a trinomial and the leading coefficient is 1, you can just set up 2 sets of parentheses. And since d times d gives us d squared, that's what we're going to put here and here. Now, I know there's some c's involved in this. I'm going to ignore that for a minute, okay? I'm just going to look at my numbers, because normally what we do is we come up with 2 numbers that add to the number in front of this middle term and multiply to the number in front of the last term. Okay, so 2 numbers that add to +1 and multiply to -2 would be -1 and +2. So -1 and +2. Now, here's the deal. Here's the difference with this. See how we have a c squared here? Do you agree that c times c gives us c squared? Yeah, it does, right? So we're going to have to put a c in the second spot in each parenthesis. Now, you might be wondering what's going on with the CD right here, but let's think about it. I'm going to double distribute this out, okay? D times D is D squared. D times 2C, wouldn't that be 2CD, right? 2CD, keep that in the back of your head. And then wouldn't, if I now have to distribute the -1C, isn't -1C times D -1CD? So if I combine the 2CD with the -1CD, that's how I get this +1CD. And then to finish double distributing, -1C times +2C is -2C squared, which is what that says. All right, so we factored this. Now, the only thing I'm going to do to help us cancel, see how this down here says D minus 1C? Usually if you have a 1, we don't put it in front of the variable. Let me see if I can erase that without messing up the whole problem here. Oh yeah, look, there we go. Okay, I'm going to leave that as D minus C, because I think it's going to help us for canceling. All right, so this is kind of like number 5. See how in the numerator it says C minus D, and in the denominator it says D minus C? Okay, it's the same terms being subtracted, but in the opposite order. remember, we're allowed to cancel those as long as you compensate for putting a -1 somewhere. Now, you could put a -1 in the numerator, you could put a -1 in the denominator, or you could just stick it right in front of the fraction. That's up to you, okay? You know what I'm going to do? I'm going to stick it in front of the fraction. So when I rewrite this, let me just, for right now, I'm going to put it right here in front of the fraction, okay? So when I rewrite this, we're going to have negative in front of the fraction, and on top we have c plus d, and in the denominator we have d plus 2c. Now, if you look at all the answer choices, none of the answer choices have the negative in front of the fraction. So if you have a negative in front of the fraction, you have to decide, am I going to distribute this to the numerator, or am I going to distribute it to the denominator? You cannot distribute it to both, because if you took this and distributed it to the top and distributed it to the bottom, it would be like we have a negative over a negative. Okay, it'd be like we have two negatives. And if we had a negative over a negative, isn't that a positive? Okay, so you have to decide where you want to distribute it. Now, let's look. In the denominator, we have d plus 2c, which they all say d plus 2c. So we don't want to distribute this to the bottom. We don't want to change the bottom. What we want to do is we want to take this and distribute it to the top. Okay, so when we distribute that negative to the numerator, negative times c would be negative c, and then negative times d would be negative d. And that's going to be over our denominator that we had. So if we look, that matches up with choice 3. All right, and then finally, number 8. All right, so this one, again, you should have tried on your own, and now you're just going to check your work. All right, so we know the first thing we want to do is we want to factor the numerator and factor the denominator. Now, when we factor the numerator, this is just dots, right? It's a difference of perfect squares. So we could set up 2 sets of parentheses, and you're going to put the square root of the first term in the first spot. So since the first term is 9, the square root of 9 is 3. And let's make one addition and one subtraction. And then the square root of x squared is x. So we're going to put the square root of the second term in the second spot in each parenthesis. And it's super important that you keep it in the correct order, okay? Please don't have x plus 3 and x minus 3. It's 3 plus x and 3 minus x. Okay, now I'm going to actually factor this off to the side because I don't want to have a big mess within my fraction. All right, so let's see. The first thing you want to say to yourself is, can I pull out a greatest common factor? And yes, you can. Okay, we can pull out a 2. So I'm going to start off by pulling out a 2, which leaves me with 5x squared minus 14x minus 3. Okay, all we did was we divided each of these terms by 2. Okay, and we put the 2 on the outside. All right, now, since I have a number other than 1 in front of my trinomial, in front of the first term of my trinomial, I know I'm going to have to do the rainbow. All right, so let's first just bring down the first term. And we know with the rainbow, right, we need to give ourselves more room because we're going to be going from 3 terms into 4 terms. When you do the rainbow, please don't try to set up 2 separate parentheses here. It's one big parenthesis. Okay, we know we bring down the first term, we bring down the last term, and we come up with 2 numbers that multiply to our rainbow number. So we're coming up with 2 numbers that multiply to negative 15 and that add to negative 14. Okay, so that would be negative 15 and positive 1. So negative 15 and positive 1. Now, since this middle term has an x on it, don't forget to put the x's on these 2 middle terms. And from here, we're just going to group. All right, so let's bring our 2 down. And then we're going to group together these first 2 terms and group together the last 2 terms. Now, out of the first 2 terms, I could pull out a 5x, which leaves me with x minus 3. And out of the last 2 terms, I mean, the only thing I could pull out of there is either a positive 1 or a negative 1. But I want to pull out a positive 1 because in the parentheses, I also want to be left with positive x and negative 3, x minus 3. Okay, so since these parentheses match up, it means we were able to factor this using the grouping method. All right, so let's first bring down our 2. And then we're going to group together this 5x and this positive 1 in one parenthesis. And then we're going to rewrite our common binomial of x minus 3. All right, so there we go. That's factored. So let's put that in our denominator. Let's go back to our fraction up here. And It looks like the canceling for today was pretty consistent all throughout, okay? Not much canceled, but what does cancel is, look, again, two terms being subtracted in the opposite order. So we know we're allowed to cancel those out as long as we put a -1 somewhere. You can put it in the numerator, you can put it in the denominator. I'm going to, again, put it in front of the fraction. That way I have the option as to, do I want to distribute it to the top or do I want to distribute it to the bottom? Okay, because you have to look at the answer choices and see how they did it. All right, now, I'm just going to bring down the equal sign, and if we look at all of these answer choices, see how the denominators all say 10x, well, actually not this one says 10x minus 2, but the majority of them say 10x plus 2. It looks like what they did was they took this 2 and distributed it into the parentheses. Okay, so when you do 2 times 5x is 10x, and then 2 times 1 is 2. I mean, I'm pretty much going to be ruling out choice number 4 because I don't think there's any way we're going to be able to get that. Now, if we look at the numerators, this says 3 minus x, this is 3 plus x, and this is -3 plus x. Well, since they didn't throw a negative in front of the fraction, they did distribute this. And they didn't distribute it to the denominator because this denominator matches up with 3 out of the 4 choices. So what they did was they took this negative and distributed it into the numerator. So negative times 3 would be -3. And then negative times x would be -x. And that matches up with choice 3.